Good day, viewers all over the world. You are welcome to Toidel online class. Today we want to look at the roots of a quadratic equation. Roots of a quadratic equation. If we recall that if ax squared plus bx plus c is equal to 0, where a must not be equal to 0, then its roots are given by x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. That is, if this is the general form of quadratic equation. And by the time we use the formula method to get how do we solve this quadratic equation? We use this formula to get the two values of x. The two values of x that we got using all the three methods that we used: formula method, completing square method, and factorization method, are called the roots of the quadratic equation. This is what we know, that if this is the general form of quadratic equation, the roots will be given by what you have on the board. But we know that b, this is same thing as minus b plus or minus square root of d. This is all over 2a, where d is equal to b squared minus 4ac, and it's called the discriminant. This d is called the discriminant. The d is called the discriminant. It's called the discriminant. So this d, b squared minus 4ac, is what we actually use to find the nature of the root of quadratic equation. We are still going to talk about the nature of the root of quadratic equation. Just note that d is equal to b squared minus 4ac, and this d is called the discriminant. The purpose of this discriminant is for us to be able to know the nature of the quadratic equation. That's why you plot quadratic graph. It's curve-like in nature, either upward or downward. It is this d that will tell us the nature of that quadratic equation. That will be the discussion for another day. Then what we are trying to say now is that if you have the two roots of quadratic equation, can we generate that quadratic equation? The answer is yes. How do we do that? We have to know the sum and product of the roots. So that will take us to the sum and products of roots. So we say x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. That is plus or minus. If x has unique root, let's say 1 is alpha. Alpha is given as minus b plus or minus square root of d all over 2a. And beta is given as minus b minus square root of d all over 2a. So one is plus, the other one is minus. We'll be able to separate the two roots now, as we have it on the board. So this is for alpha, this is for beta. Then how do we find the sum of this root? The sum by formula, alpha plus beta is the sum. That is, the sum of the roots will be minus b plus square root of d all over 2a plus minus b minus square root of d all over 2a. If you find the LCM from there, if we find the LCM from there, the LCM will be 2a. Then we are going to have minus b plus square root of d minus b minus square root of d. At the end of the day, this will cancel this. Then we have minus 2b all over 2a. 2 will cancel 2. So sum of the roots by formula is given as minus b all over a. This is the sum. This formula to find the sum of roots. Then if we know the sum of roots, we go ahead and find the formula for products. The products, where we have alpha beta, the product will be minus b plus root d all over 2a multiplied by minus b plus minus root d all over 2a. Then if you multiply this, we are going to get b squared that will be plus b root d minus b root d. Then this will be minus d because square root times square root. Then all over 4a squared. This will cancel this. At the end of the day, we have b minus, what is d? D is given as b squared minus 4ac. That is discriminant. That will be minus b squared minus 4ac all over 4a squared. Then if we open up at the numerator, this is b squared. We are going to have b squared minus b squared plus 4ac all over 4a squared. Minus b will cancel b. At the end of the day, we are left with 4ac all over 4a squared. 4 will cancel 4. A will take care of 1a. So the product by formula is given as b is given as c. The product by formula is given by c all over a. This is formula to find the product of the roots of quadratic equation. This is for sum and this is for the product. So now, if alpha and beta are the roots of quadratic equation, how do we generate that quadratic equation? That is the bone of contention. That is what we are about to derive now. So if alpha and beta are the roots of the quadratic equation. So how do we generate that quadratic equation? That is, if we say x minus alpha into bracket x minus beta equal to 0, then if I expand, I will have x squared minus x beta